Hey guys, welcome back. This is section 2.2. It's properties of matrix operations. So in this section, we are going to talk about the properties of matrix addition, scalar multiplication, and zero matrices. We're going to discuss the properties of matrix multiplication and the identity matrix. I think I said multiplication up there, but I meant addition. And then find the transpose of a matrix. Okay, so these are basically the do's and the don'ts for operations with matrices. All right, so a couple of things. First, the commutative law of addition applies. So a plus b equals b plus a. In order for us to add two matrices, we have to make sure that they have the same sign. The same size. So a would have to be n by m, and b would have to be n by m, and we learned in the last section you just add the element in row 1 with the element in row 1, and so on. It doesn't matter which way you add them. You can add a plus b first or b plus c first, and you'll still get the same answer. The additive identity, there exists a zero matrix such that a plus 0 equals a. So if you think about it, if you have some sort of 1, 2, 3, 4, and you add it to 0, 0, 0, 0, 1 plus 0 is 1, 2 plus 0 is 2, 3 plus 0 is 3, and 4 plus 0 is 4. So that works. And also, if we have a matrix A, plus the negative of A, that's going to equal to 0. So some of those are pretty simple to just say, yeah, that makes sense. When it comes to scalar multiplication, just remember scalar means it's going to be a product that you're going to multiply each term in the matrix by. So in this case here, we're going to let A and B be matrices, KP be scalars. So the distributive law over matrix addition works. So you can do a plus b, then times it by k, or you can do k times a, and then k times b, and that will give you the same answer. Here, you might have two scalars, okay? So, and you want to multiply the sum of the scalars, k times a, p times a, okay? So you could basically factor out the a in this case. Okay, associative law for scalars, doesn't matter if you do p times a first or k times p first, and then our identity, if we multiply the matrix by 1, you'll get back the same exact matrix. So here's a good question. Solve a matrix equation. I'm going to give you a, b, and I want to solve for x. So 3x plus a equals b. First thing I'm going to do is I'm going to minus a to the other side, and then I'm going to multiply by the reciprocal of 3, which is 1/3. So we're going to do b, which is 3, 4, 2, 1. I'm sorry, negative 3, 4, 2, 1. And then we're going to subtract that from a. We're going to subtract a from b, 1, negative 2, 0, 3. We're going to come up with this, right? Take a look. How do we subtract element with element? Negative 3 minus 1, negative 4, 4 minus a minus 2, 6, and so on. And then we're going to take 1/3 of that, which is a scalar, okay? So 1/3 of negative 4, 1/3 of 6, and so on. So that's how we can solve for that, all right? In the next one, this is probably the most important thing. Matrix multiplication is not commutative. Okay, so now in this, we're talking about the properties of matrix multiplication. Matrix multiplication is not commutative. This is very, very important. A times B does not equal B times A. It could, but it's not necessary that they're equal. Another thing is sometimes you won't even be able to do it because remember, n by m, m by p, these have to match. So if this was A and this was B, that would be n by p. If you reverse them and you did m by p and then n by m, you can't even multiply them, okay, because these don't match. So commutative property is not always equal, okay? Matrix multiplication is distributed over matrix addition. So we have a plus b times c to equal ac plus bc. This is called the left distributive property, and then a times b plus c is called the right distributive property. It's very important to actually know those words, okay? So this is where you're left, right? You're going like this way, to the left side, to the right side. Okay, matrix multiplication is always associative, which means it doesn't matter which you multiply first. A times b times c is a times b times c. And then here, A is a square matrix of order n by n. Square matrix just basically means that the number of rows and the number of columns are exactly the same. And I is the unit matrix of the same order. Then A times I equals I times A, which equals A. So this is a case where commutative property does work. Okay, so let's take a look here. I felt like doing one quick example. I didn't go through everything, but if this is A, this is B, and this is C, this is a 2 by 2, this is a 2 by 3, this is a 3 by 2. Okay, if I did A times B first, I would take this, 1, negative 2, 2, negative 1, and B. Now, once again, guys, you can just use your graphing utility, but I'm going to show you the long way because I prefer to just constantly restate it, right? So here's row 1, here's column 1, and that will give you row 1, column 1's answer. So 1 times 1 minus 2 times 3. So that's going to give you 1 minus 6, which gives you negative 5. If you want the person below, you do second row, first column to get this person here. So you can use your graphing calculator. A times B gives you negative 5, negative 1, and so on. You could pause the video to look at the work. AB times C. Now you're going to take this, and you're going to go, in order to get, first of all, this is 2 rows by 3 columns. This is 3 rows by 2 columns. Therefore, you're going to get a 2 by 2. So with that being said, if you want the first row, first column, you have to take the first row, first column. So this times this, and that should give you 17, and so on. I did the work here. Negative 5 times negative 1, 4 times 3, 0 times 2. That gives you 17. And each one. If you did it in reverse, again, you can use your calculator to show B times C, gives you this, and then times it by A, and you get the same exact thing. So that's an example of the associative property working. You obviously can't show proofs through example. You can show that some properties don't work by setting, using what they call a counter example, and that will disprove it. But to prove something, you have to use it like generically for everything. So I think, I wrote this already. Commutative property fails. A times B equals B times A. A may be equal, but not always. This is something that's really important. Cancellation is not valid. So if A times C equals B times C, then A doesn't equal B. Could it? Possibly. Most of the times, it won't. So I did A, B, C. A times C would be this times this. B times C would be this times this. When you take a look at it, A times C gave me this. B times C gave me this. So therefore, A times C equals B times C. But what is A and what is B? Right away, we notice that A is 1301 and B is 2423. So they're not equal. Please do not go like this and cross off the C's and say A equals B. That does not work. So this chapter is not about, or this section is not about knowing how to do the problems. Hopefully everybody knows how to multiply matrices. This is about properties that work and don't work. So right now the commutative property does not work for multiplication, but obviously works for addition. And the cancellation here does not work. So those are very important. I think I'm going to leave off with this last slide. Square matrix, like I said before, is 2 by 2, 3 by 3, 4 by 4. The identity square matrix is basically the row reduced echelon form without the constants at the end. So it's one, all diagonals of 1 and every place is 0. So this is for a 2 by 2, this is for a 3 by 3. All ones, 0, 0, 0, 0, 0. And basically, as we mentioned before, the properties of the identity, if A times I is equal to A, I times A equals to A, therefore this place, the commutative property does work. Okay, so I think I'm going to stop here. Let me just see. This is an example of how the identity does work. Okay, so we go, I did this again. This is a 2 by 2, 2 by 2, so I have 2 by 2. Take the first row, first column, 2 times 1 plus 1 times 0, 2 times 1 plus 1 times 0. That gives you the 2. To get the first row, second column, you're going to go 2 times 0 plus 1 times 1, and you'll get back your exact, what we call A. So typically, you should be doing this stuff through discovery. So I'm going to stop here, and then I'm going to make another video for the continuation of this.